Today, I want to talk about how to run ArgoCD at scale to be able to run more than 1,000 applications. And this is my life story. Right now, I'm working as an employer in Kubedemy. Kubedemy is a Kubernetes academy. We're providing training courses about Kubernetes and everything related to Kubernetes. And I'm working as an employee in CBRE. CBRE is a leading company in construction, building, and real estate. And I'm working there as a Kubernetes architect director. And I'm a software engineer, writing codes in Golang, Python. I prefer to use open source unless company and our users, clients, enforce them to use non-open source technologies. And I also contribute to open source technologies like Kubernetes, ArgoCD, and a couple of other open source technologies by writing codes, documents, technical articles, and something like that. I go climbing, mountaineering, mountain biking, just like that. And my baby is on the way. And if somewhere everything related to Kubernetes, I will be there. That's what I do. OK, so our agenda today is to look at ArgoCD components and deployment patterns in ArgoCD. And after that, we have the first thing about running ArgoCD without any tuning, without any optimization, and deploy 1,000 applications and check what really happened. And after that, we go a little bit deep and tune ArgoCD, and then try to deploy again 1,000 applications and see the results. Before I start speaking, please scan my QR code. Start. Don't be lazy. OK. ArgoCD Architecture. The ArgoCD architecture provided by documents is something you can see. This is an API, application controller, repository service, Kubernetes, and you have something hooks, clusters, and the user can communicate with the UI and CLI and a couple of other things. But it's just a joke. Because when you want to work with some application and you want to deploy application at scale in enterprises, you need something else. You need a deep dive architecture, and you need the internal architecture about how these components work together. And it made me to design something else and go deeper than the main architecture provided by official documents, and this is the real architecture. When you have and when you deploy ArgoCD into your cluster, you have the ArgoCD server, you have the application controller, the ArgoCD application controller, repo server, notification controller, application set controller, and in addition to these main components, one DEX server will be deployed in addition to the Redis. And the main components in that system is a repo server and application controller. You can deploy ArgoCD without server, DEX, notification controller, application set, but you have to and you must deploy application controller and repo server. And Redis is used as a cache, and I will tell you what really do. Application server is responsible for syncing namespace, application, sync wave deploys, update the cluster information, apply chains, and apply app cluster sharding. And when you create your first manifest, the application manifest, application controller send a request to the repo server and ask for the manifest. The real manifest should be deployed to the cluster, to the Kubernetes cluster. Repo server will clone your application from the Git and create the manifest, generate the manifest. It depends on your application. If you use Helm, it has a Helm. If you use Customize, it has a customized binary. And it supports many other things. And when the final template of your manifest gets ready, it pushes it to the Redis and cache, as a cache, and then provides a ready-to-go manifest to application server. And then it will be deployed to the cluster. When we talk about the server, server provides UI, authentication, authorization, RBAC, and to read logs, allow you to use a container shell. You can open the terminal through the UI, but the main thing about the server is it has nothing to do with the resources, and it has nothing to do with the application or syncing or anything. So it's not a bottleneck. And if we look at the notification controller, again, it doesn't work with the main components, application set controller again, and Dex server again. So in that system, the main components are application controller and repo server. And the Redis. So if we want to tune our system, our ArgoCD instance, we have to scale, and we have to tune and optimize repo server and application server. What's the deployment pattern, and which deployment pattern can be used with ArgoCD? We have a couple of typical deployment pattern in ArgoCD that you can have one repository. Inside that one repository, you have one microservice. You have one Helm chart in that repository. And you create an application manifest and put it into that repo. And then you can deploy it. It's a normal deployment. But when you go to real production server, as a DevOps engineer or platform engineer or Kubernetes engineer, you can't get access to push something to the developer codes and to the main repo about the application, and you have to do something else. In addition to the application repo, you have your main repos for the deployments. And in that case, we have one repository for ArgoCD applications, many repositories for microservices we have, and Helm charts in their microservices repo, and we introduce the pattern of app of apps. And app of apps is something like here. We have the main application in ArgoCD, points to the application repo. Inside the application repo, we have a couple of YAML files. All of them is, again, the application manifest, is the ArgoCD application manifest, points to the main repo, to the application repo, to our microservices repo. And then we can deploy it. Another pattern is to have one repository for all manifests and another repository for our charts. This is the most common pattern in enterprises. And in that case, you have to deploy the main application. It points to application manifest repository, and application manifest repository points to the charts repository. This is the most common, and almost all the companies use this pattern. OK, so when we talk about this pattern, we want to check what really happened if we try to deploy 1001 application, because we have one application here, we have 1,000 applications here, and this is 1,001 applications. What really happened? What do you think? Without any optimization, without any tuning. This is what happened. Yeah. And this is the Grafana result. Anyone can analyze it. what's really happened in the infrastructure? Take a look. I'm sure you can, but this is what's really happened. When you deploy your application, 1,000 application, you can see here, this is 1,000 application. After deploying 1,000 application, the Argo application controller gets restarted because it can't support. After that, it's coming up again, and because of the huge load, it gets restarted again, and again, and again, and again, till here. Then 1,000 application is ready. 15 minutes take long to deploy 1,000 application. 10 minutes to sync one application if you change in monorepo. If you change something here or change something here, because of the default configuration, what's really happened is, you can see that, everything goes down, and you can see out of sync of application, we have some out of sync here, and you can see what happened. You had 1,000 application in a healthy mode. All of them are healthy here. And after changing one application, one chart, what really happened? All applications will be tried to redeploy again because of the cache validation. And it's due to you didn't optimize and tune your ArgoCD. So, how we can optimize and tune our ArgoCD is a couple of patterns and a couple of problems we have to solve. It's about 20 problems, but today I just, because of the time, I just tell you 10 most problems you can see in your environment and how you can fix it. And after that, we fix all of them and deploy and ArgoCD again. The problem is many clusters. We have many clusters to manage. And memory usage in application controller, we go beyond what we think. The solution is increase ArgoCD application controller replicas. It's a main idea. And when you want to do that, you need to change the stateful set application replica in addition to one environment variable to tell ArgoCD, OK, there are 3 instances of application controller in place. Now you can distribute applications. And after that, we have the sharding algorithm. By default, is a legacy. But you have to change it to the round robin. Because the legacy mode picks based on some stupid algorithm that when you have one application controller in place, first time it found, OK, I have to distribute for this cluster. And after a while, if you add a new cluster, your environment gets growing. And if you add a new cluster, there is no any application controller to manage because it's something fixed. When the ArgoCD application controller gets up, check for all the clusters, and it distributes, and that algorithm just check the current clusters you have, and then try to distribute. And if you add something new, you have nothing. The next thing is you have many charts, as like we discussed, and manifest generation in repo server is too slow. You have to enable concurrent manifest generation in the monorepo mode. And it can be done by adding one file, .argocd allow concurrency, and it tells you to ArgoCD repo server, my Helm chart has nothing to do with each other. It's not dependency. If your application, if your Helm chart are dependent together and all of them placed in one repo, you don't need to add this file. But when we talk about microservices has no any dependency in their Helm charts. You can deploy all of them. And to solve this issue, you need to add this file. The next thing is a small change in your repo change and use high memory in a repo server, and you have slow reflection. It's because when you have all your charts in one repo, ArgoCD by default use the SHA hash of your commit as a key in the Redis, as a cache. And what really happened when you change one chart, it means the SHA commit gets changed. And right now you have 1,000 charts with the same SHA commit, and when it gets changed, it tries to generate all the Helm charts again and again and again, and try to cache it in Redis. And it needs more time. To solve it, you need to add a new annotation into your application manifest and tell, OK, this application in our chart repo use this path. And when something changed in the main repo, in the, our chart repo, if it's related to this path, ordering service chart, just refresh the cache for this application. It has nothing to do with other applications and other charts. And to make it fast, you need to use webhook. Instead of waiting for reconciliation time in ArgoCD, you can use a webhook. The next thing is optimize maximum manifest size for directory plugin. And the problem is raw manifest caused high memory usage in repo server, and after that, out of memory kill. And the solution is allocate enough memory and reduce maximum manifest size. By default, your applications, if in a repo server, we have a couple of plugins. Directory plugin, Helm plugin, Customize, JSON.NET, and you can bring your own plugin with the CMP. But for the directory, the default is a 10 megabytes. And imagine you have 1,000 applications. The thing about raw manifest is in memory manifest, maybe as much as 300, more than the normal one, and the file size. And it's because of the Golang YAML engine. It's not about the ArgoCD. Try to use Helm chart, customize instead of raw manifest. Sometimes, in some companies, to deploy their application through ArgoCD, they template their Helm charts and make a ready-to-go template and push it to the GitHub repo, and the ArgoCD see them just like a raw manifest. Don't do that. Change the maximum size. For example, for if you want to deploy and you crazy about deploying raw manifest, and you have 1,000 applications, you need 300 gigabytes of memory in theoretical use for just a repo server. So you must not do anything with the raw manifest. Just go for Helm, Customize, and other solutions. The other thing is optimize manifest generation parallelism limit. The problem is repo server out of memory killed. It gets started, killed, restarted, killed. And it's because in a default configuration, what we have, the default configuration tells about how many Helm charts can be generated at the same time. The default is 0, and 0 means infinity. You can generate as much as you can. And when you have 1,000 applications, 1,000 Helm charts, it tries to generate all of them at the same time. And boom. Helm footprint for a big chart needs 60 megabytes of memory to 100. And for example, 1,000 application, it's good to change the limit to 50. And this is another thing you should do. Optimize the manifest generation timeout and Git attempts. The problem is you have many repos, and the huge manifest and generation time, you get the generation timeout and Git failure. Because ArgoCD tries to fetch and run ls remove command continuously to check what really happened in your Git. And how you can solve it, increase the execution timeout and Git attempts. If you have a big chart, you need to change the ArgoCD exec timeout variable. The default value is 90 seconds. And if you need more, you can do that to find if the commit gets changed and you change something in the Git. It continuously check the repo with a git ls remove. And what really happened, when the first try gets failed, because it's a one try, the ArgoCD repo server doesn't try again to fetch the change. You should change it. And after that, when you get the application controller shows you context deadline exceeded, you need to increase fetching timeout and scale repo server. What really happened, as discussed, when you create an application controller send a request to the repo server and ask for manifest. When the manifest is huge, it gets timeout. And you need to change the timeout, the default timeout in the controller. Another thing is about optimize the cubectl apply parallelism limit, because when you have application controller in place, application controller deploy and sync and change everything through cubectl apply with just a running comment. And it forks a cubectl binary, and the default value is 20. Imagine you have 1,000 applications. If you need to be more fast, you have to increase the number of cubectl can be forked at the same time. The next thing is optimize application controller queue processors. In an application controller, we have 5 processors, but you need to take care of two of them. The status processor is responsible to get the application info, fetch the information from the cluster. OK, what is the health of application? What is the status? And we have another queue and the processor to do is an operation processor, and is used to apply the operations. For example, upgrade the manifest, deploy application, sync, and do anything related to operation stuff. The next thing is about the cache expiration and the reconciliation timeout. This is the last one. If you take a look at the Redis, how many keys we have? 5,006. We have 1,001 application, and in Redis, we have 5,006 keys, which means for each application, you have 5 records. That points to some cache about the application. You can see that. The manifest, app managed resources, app details, the generated manifest, and all of them cached to the Redis. And you need to change some default values about the cache expiration if you need to do that. It's something tricky. And you should be aware of that. Increasing repo cache expiration can cause delays if your application has some external dependency. For example, your application needs MySQL, Nginx, and you add all of them as a dependency of your main chart. Because it's out of the scope of your repo, the main repo, if their application gets changed, you need to be aware of that. And is it done? Of course not. It's just 10 most common problems you will face when you work with ArgoCD at scale. Something like self-healing timeout, dynamic cluster distribution, right now is alpha, resources persistent, failed manifest generation, and other things. You have to take care of about all of them. And now is it time to deploy ArgoCD with tuning with a 1001 application. This is the configuration. This is the override we have about the timeout, the reconciliation timeout. Is that 1 hour? We have some parameters about the timeout of repo server, controller optimization, Redis optimization in the memory, in resources, CPU and memory, controller optimization, the number of replicas, and repo server optimization, adding auto-scaling, adding 2 additional environment variables. And now it's time to run. This is what really happened. Now your application, 1,000 application in the same cluster with the same circumstances, deployed in 8 minutes instead of 50 minutes. When you change one application, one Helm chart, you can't see anything here because it's deployed just in click. And for example, changing 250 chains, 250 chains in your Helm charts, in your applications, at the same time, you can see that just 250 of application goes out of sync. And we have no any restart in ArgoCD application controller. This is what we had before, and this is what we have right now. OK, this was my talk. If you want to learn more about Kubernetes, you can go to kubedemy.io. If you're looking for a free course about EKS, how you can deploy, manage, and do anything with the EKS, you can, right now you can register for free. And if you're looking for enterprise-grade ArgoCD workshop, you can contact me. And questions?
First, can we thank Saeid?
You need one bonus? I have one bonus. What is my question? As I said, application controller need to deploy. And if you want to manage it at scale, for example, right now, we have 500 clusters. Let me get back here. OK. As you can see, the repo server can be managed with auto-scaling. But controller cannot be managed because it needs additional environment variable. How you can automate it? Is it part of question? Instead of asking question, I have a question. I will show you how we solve it at the enterprise.
So in the Argo docs, if you want your controller to run in HA, they ask you to add extra variables, extra environment variables. You can use that in the customized overrides. I should do it.
So it's fine, but it has some problem. Any other solution? Let me show you what should be done. This is what I do as Kubernetes architect. and show you what really happened at the enterprise. OK, this is what we have. So we have a management cluster with ArgoCD in place. It points to our add-ons repo, our overrides repo. It gets everything from the repos and push it to the main clusters. And right now, we have ArgoCD in place. We have a Prometheus. That Prometheus scrapes the metrics of Argo. And based on some rules, finds, OK, it's time to scale application controller. It pushes some alerts to the alert manager. The alert manager triggers the Argo events with the webhook. Argo events trigger our workflow with the Argo workflow. Argo workflow run an update pod. This pod, when it started, clone that overwrites repo, read the Prometheus metrics, calculate the number of proper replicas it should have, change and update the values, push it again to overrides repo, and because of it get changed here, this application, this ArgoCD, redeploy the application. This is what we do at the enterprise grade level.
Thank you very much. I think we're out of time now.
Yeah. Thank you all.